Hello everyone, this is my third task submission in Sparks Foundation. This is related to decision trees. So here I am importing necessary packages and then I'm reading the dataset. Let's check the shape. Now I'm dropping a column as it provides no valuable information. Making some other changes. We can see here that our dataset is balanced. Now we are plotting the violin plots to see how the data is distributed. Now here we're performing the train test split. Stratify equals to y ensures that our data set is balanced in training set as well as a test set. Here we are importing the decision tree classifier and metrics. This will help us to visualize the tree. These are the two functions. This will help us to visualize the tree, and this function will print the training accuracy and various metrics related to the testing set. We are more interested in the testing set because regression trees often tend to overfit, so their performance on the testing set is more important. Now we are running our model. So here we can see the splitting has been done and the maximum depth is 1, 2, 3, 4, 5. These are all the leaf nodes. They have no child. This is the root node, and here we can see the criterion has been used. Here is Gini, which is a default criterion. Here 40 40 40 means there are 40 instances each of Setosa, versicolor and virginica. Now here we have given labels like Setosa, versicolor and virginica, so in that order it is showing. Let us see another node. Yes, let us see this node. Here class virginica means that class which has the maximum number of instances. Here we can see it is 4, which belongs to virginica. There's 2 instances of versicolor and 0 instances of setosa. Let's check another node here. Let's see here. Total number of samples is 39. It has 38 instances of versicolor and only 1 instance of virginica. Let's check the metrics. Training accuracy is 1, which means that it is 100% accurate in the training set, but we are more interested in the test set. So here we see a precision, recall and F1 score. Support here means number of instances. Just 10 instances each of setosa, versicolor and virginica. Now here let's see the confusion metrics, and then we will just cross verify with the metrics we are seeing here. So let's check with virginica once. Precision, here the precision is as it has been described what is precision and what is recall and what in F1 score. So we will cross verify it. Here precision of iris virginica is 0.91. So here these are the true levels, these are the predicted levels. So here we can see that 11 instances has been predicted as iris virginica, and out of them 10 instances have been correctly predicted. So let's see, 10 divided by 11 is approximately 0.909, which it has been rounded up to 0.91. Now let's see the recall here. Recall how many total instances of iris virginica were actually there. There are 10 instances and 10 has been correctly predicted. So here the recall is 1. Now let's see the recall for iris versicolor. There are There has been 10 instances of iris vertical and out of them 9 have been correctly predicted. So the recall is 0.9 and F1 score is the harmonic mean of these two. Here the macro average and weighted average both would be equal. So here we can see that there is no difference in macro average and weighted average since it is a perfectly balanced data set. Now let's change the max depth to 3 and here we can see that max depth here is 3 and you can see the matrix here. This model seems to be perform better than our previous. It is almost same. It's almost same. Now let's change the criteria to entropy. And here we are setting criteria entropy and max depth as 3.